Like, what's bridging coins and tokens? We already talked about this. It means moving assets between two different blockchains, Ethereum and Solana. In this video, I try to summarize and reflect my understanding of bridging. Since blockchains are isolated systems, they don't talk each other natively. The bridging process is essential: a lock and mint, or burn and release method. Or there is also an opportunity to cross-chain messaging bridges. It's more advanced. I will come to that point too. This is as much as I can make it basic. The lock and mint, the most common way to send tokens between chains. You send Ethereum, ERC20 token, to a bridge smart contract on Ethereum. Contract locks your token. They are frozen, not destroyed. The bridge system, sometimes centralized, sometimes decentralized, then mints the wrapped tokens on Solana that represents your Ethereum. When you bridge back, the wrapped tokens are burned on Solana and the original Ethereum is released on Ethereum. And the other mechanism is burn and release. Instead of locking, your tokens are burned on chain A, then released from reserve on chain B. Rare but used in some design. For example, Cosmos IBC, inter-blockchain communication. The mechanism is when you send tokens across chains in Cosmos, token on the source chain is burned and the equivalent token is released or minted on the destination chain. Why? Cosmos treats tokens as native IBC assets, so there is no permanent lock on. Supply is balanced by burning and minting events across zones. Cosmos IBC is a trust minimized grid. It uses light clients and proofs, not multi-sigs or centralized custodians. Polkadot and Kusama mechanism is transferring dot between parachains, works by burning the asset on the source parachain and releasing it on the target parachain. Why? The relay chain enforces global token supply, so the burn on one parachain is final and the target parachain reserve issues redeems accordingly. Example, moving dot from the relay chain account into a parachain like Akala involves a burn and release event. Another example could be Algorand ACA bridges. Some Algorand bridges use release for cross-chain swaps. For example, an ACA Algorand standard asset may be burned on Algorand and then released from custody on Ethereum or by smart native token wrappers. Less common but relevant. For example, Terra Classic for collapse had mechanisms where rapid versions of Luna and UST were their one-on-one USDT stablecoin on other chains would sometimes handled by burning and releasing reserves. Instead of indefinite lock contracts, they are using this one. Why it matters? While most bridges use lock and mint, some ecosystems like Cosmos IBC and Polkadot use burn and release. The tokens are literally destroyed on the source chain and then released from reserves on the destination. This keeps circulation supply constant and removes the risk of inflated rapid tokens. It's more trust minimized, but also more complex to implement, since the chain must be able to cryptographically verify the burn. And we can jump into now examples of cross-chain messaging bridges. Layer 0. How it works: it uses a ultralight nodes ULNs that allow one chain to verify transaction events on the other chain without storing the full state. Components, relayers, forward transaction proofs, oracles provide data about event source on source chain. Use case is sending not just tokens but arbitrary messages, contract calls, governance votes, something like that across chains. For example, Stargate Finance uses layer 0 for liquidity transfers between chains. Axelar functions as a general purpose messaging protocol with its own centralized validator set. Again, DApps can call contracts on other chain if they were local. A DeFi protocol on Ethereum can directly interact with liquidity on Cosmos or Avalanche via Axelar's messaging layer. Wormhole, the advanced mode. While Wormhole is best for known token bridging, it also supports generic message passing. Example, cross-chain governance. Ethereum can be recognized on Solana, something like that. So why messaging bridges are more advanced? They support any data. They rely on light clients and validators or cryptographic proofs, making them more trust minimized than custodial token bridges. They enable composability across chain. So cross-chain messaging bridges like Layer 0, Axelar and Wormholes are message layer go beyond token. They transmit proofs and contract calls across chains, allow true interoperability. For example, a governance on vote on Ethereum could trigger a contract execution on Solana. This is more advanced than simple lock and mint bridges, the first one, because it enables arbitrary cross-chain logic and reduces reliance on centralized custodians. Since chains are isolated, we look for bridges. Bridging usually locks tokens on the source chains and mints rapid tokens on the target. To trace money, we follow the trail. Original tokens are locked, rapid tokens are minted. Using Explorer and forensic tools, we cluster addresses, tag known entities, and monitor whether funds go to exchange, mixers, or DeFi protocols. The best method is entity-based clustering with forensics platform. While the worst is ad hoc manual tracing without considering obfuscation techniques, the tracking funds in crypto is often called blockchain forensics. Unlike banks, all blockchain transactions are public, but users hide behind pseudonymous addresses. In the end, there are three types of tracking categories: best tracking method, worst naive methods, and ad hoc methods. The best tracking methods are blockchain explorers, basic level. You can go to inside Etherscan, SolScan. You follow transaction by wallet or token contract. Clustering at heuristic, intermediate level. Channel analysis, TRM labs, elliptic use heuristic like same IP withdrawal pattern like same owner. Change addresses in Bitcoin, identifying centralized exchange wallets, tagging known entities. Exchanges, mixers, DeFi protocols often have known wallet clusters. Once a wallet interacts with them, its flow is easier to track. Cross-chain forensics, specialized tools trace rapid tokens across bridges. Tornado Cash Bridge, Solana. Naive methods, the worst methods. Following single wallet transaction without clustering is bad. Assuming H addresses a new person, ignores multi-wallet use. I mean, Bitcoin core wallet, we can create many addresses, many new addresses. So they are included in our wallet. Ignoring mixers, privacy chains, Monoran, Zcash, or decentralized DEX swaps. And there is ad hoc methods, manual tracing on explorers, using open source scripts with APIs, checking community-driven tags on Etherscan on forums. So if we come to tracing a bridge transaction from Ethereum Solana via wormhole, this chart shows a lot. First, the bridge locks token on Ethereum using a smart contract. Guardians observes this lock and trigger minting of equivalent rapid tokens on Solana. I would use Etherscan to confirm initial lock, then SolScan to verify the mint. Optionally, I could trace subsequent activity like swaps or transfer in the Solana ecosystem. For serious forensics analysis, clustering tools, chain analysis, Nansen addresses entity behavior across chains. Let's walk through a realistic, traceable example of bridging. We can initiate a bridge on Ethereum. This is the lock phase. We will wait the Guardian consensus and mint on Solana. Redeem rapid token. A rapid token is tokenized version of cryptocurrency that lives on different blockchain than the original. Backed 101 by underlying asset, like rapid BTC on Ethereum. Trace the flow. Manual forensic steps. How can we do that? We can go to the Ethereum Etherscan. We will locate the transaction ID that locks tokens in the wormhole contract, the TX. We can go inside Solana SolScan, find the mint or transfer, deliver rapid tokens on your wallet. I mean, we are following the IDs now. Linking the both, we cross-reference timestamps, token amounts, and transaction detail to tie them as one chain crossing event. Optionally, swap. If you swap rapid token, maybe rapid Ethereum, into native Solana or USDC on Solana, platforms like Jupiter Exchange can be referenced. And finally, I cannot pass this video without telling something about Avalanche. And what is Avalanche as a chain? What is the Avalanche involved in all of those? Avalanche plays two roles here. First, as an independent EVM compatible chain with fast finality and cheap fees. Second, a bridging hub. Its native Avalanche bridge connects Ethereum on Avalanche, locks token on Ethereum, and minting rapid equivalents on Avalanche. Beyond that, Avalanche participates in cross-chain messaging via systems like Layer 0, Wormhole, making it an important piece of the broader multi-chain ecosystem. Avalanche also connects other ecosystems through bridges like Layer 0, Wormhole, Axelar, Allbridge. These let Avalanche interact not just with Ethereum, but also with Solana, Cosmos, Polygon, and others. In the end, Avalanche plays two roles. It's fast, low-fee alternative to Ethereum with full EVM compatibility. Many DeFi protocols, Aave, Pearl, Trader Joe, run here. It could be a bridge hub. It provides its own Ethereum Avalanche bridge for liquidity. It also plugs into cross-chain messaging bridges, making it part of the multi-chain economy. Why it matters for tracking? Avalanche is often used in money laundering trails after hacks because cheap fees and fast bridge. Investigators often follow Ethereum Avalanche bridge, C-chain, DeFi, stablecoin swaps, exchange withdrawals. This makes Avalanche harder to track money, but essential to know because most of the money laundering trails often use this hacks on Avalanche. Thank you. Please don't forget to subscribe and like this video.